Thank you for coming. Actually, my name is Junior. I'm an engineer working in Switzerland, Zurich. And I work in a small company called Edilini. We do marketing games for big brands. And today I'm going to talk about compositionality or composability in Swift. What actually means to compose things in Swift? What is compositionality? For some developers, compositionality or composability is the way to control complexity. Bragan Beckman is an ex-engineer of the .NET team and created a lot of nice projects. And he says that compositionality is the way that we have to control complexity. And for me, compositionality or composability, it's a way to create software starting from small bricks. So it's a kind of a Lego construction. So we create very small chunks of code, and then we compose them together in a functional way. But before talking about this, it's good to take a step back and see how we performed composability in ObjectiveC, because it's because it's very important to understand the past so we can actually understand the future and see where we are going. So how things are composed in ObjectiveC. The question can be a little bit non-trivial. If you think a little bit, you can get the answer. But the very basic, the fundamental of composition in ObjectiveC is this: semicolon. We compose statements. We say to the machine that it has to do this, then that, and then we had some if, else, while, for. That's composition in an imperative way. And then we have to manage state. That is actually something that sometimes is very hard to achieve. And we perform side effects all the time. We have methods that takes nothing and returns nothing. That in mathematics doesn't have any meaning, because if nothing, it's just nothing. And this is actually a code example. And we do that, this. And then when it comes to do asynchronous programming, we hand in the callback hell. And then we start to have edge checks. The question now is this actually the same in Swift? Do we compose in the same way in Swift? Well, if you check Swift a little bit, you can say, well, it's still an imperative language, it's protocol-oriented. So basically, yes, but there is one important thing to remember. There is no more semicolon. So we are missing the composition basic thing from ObjectiveC. So we have a lot of new opportunities. How I create composition in Swift, how I can compose things, why I can compose. That's actually the big question. And if you think a little bit, there is this nice new thing coming in Swift that is first-class citizen functions. So let's compose functions. Let's try to compose functions. It seems a good idea, at least for me. So let's try to compose functions. But before, we have to understand what is a function. Because in ObjectiveC, there is no function. We have methods. And a method, it's something a little bit different. And in Swift, a function is just data. It's like integer, array, floats. Anything that we can define as type is data. So a function, it's like this. It's just data. From ObjectiveC, it's very hard to say that function is actually the same thing of NS data. Let me try to explain to you that there is nothing really strange on it. If you take the sinus or cosinus function and you have to code it, at some point maybe you cannot actually create the real function, and you have to create a table look, and then you map this x and you have this epsilon as a result. So what you actually are doing is creating a table and mapping all the values. And creating a map, it's data. So we can replace almost any function with a table, if you think about it. You have an input and you have an output. And we can remove the code and replace it with a table where we iterate inside when we need in-between values. So function is just data. What can I do composing data? Because it's a function, it's data, so we can compose data. We can do asynchronous programming, we can do error handling, we can create complexity that we tame and we have under control with small chunks, with reusable functions. And of course, there is no space for all this nice stuff that you can do composing data. I'm gonna just focus on the two, error handling and asynchronous programming. In a nutshell, compositionality or composability in Swift use a lot of generics. It's very useful using generics because the type checker is going to be our best friend. So every time we try to compose types that have generics, the system, while compiling, it's going to check if they are correct, and if there is an error, it's going to say, well, there is something that doesn't work here. Let's see a first example of composition of types. Result. How many of you are aware of the result type in Swift, or have used the result type in Swift in the last 2-3 months on the last projects? Okay, a few of them. How many of you are actually working in Swift all the time? Few more. Okay, result is a type that we use in Swift to understand if a function or a task succeeded correctly or returned an error. Basically, we can have two paths in this case. A success, that means that our task is holding a value, or an error, it means that we have, of course, an error. And an error in Swift can be of NS error type protocol, or eventually an NS error. But what can we do with result? We can go a little bit one step further, and with result, we can chain them. So this is actually what it's the result. If we take the first task, and if we have an error, it goes through the chain immediately. We don't perform any other operation. If instead we have the correct path, we go and proceed correctly to, or that it's called a happy path. So we are happily completing our task. But result is synchronous. And we want to achieve as well asynchronous programming. We don't code on a single thread. We want to see, and we write all the time asynchronous code. So what is the solution to take the same concept or a similar concept or something different and have asynchronous programming all using compositionality and composing our task? The second example is a future. A future is as well a type and introduces latency. It works very similar as a result. Actually, in the implementation of in Swift, it uses a result to handle the callbacks. And propagation is similar. And as well, the error handling is similar. What we have here, if we have a completion correct, we go on the success block. If we have an error, we go on failure. So it's basically the same. It's similar. It's actually the same. But on the first example on result, it was a single thread. And here we have asynchronous programming, so we can decide on which thread we're going to run our code. We can decide on which thread goes the task, on which thread goes the success block, on which thread goes the error. It's the same exact concept. So it's awesome, because it's actually the same thing, but we we have a new component that is called latency. So we can create asynchronous code without having to know another concept, because what we already saw, it's actually the same. But talking, it's very hard, because when you talk about future promises, monads, functional programming, sometimes it gets very hard to understand. And I think it's better if I show a nice example how to use it. Okay, perfect. Okay, so I created this small application for my personal usage, of course. And considering that I'm from Switzerland, I need to understand the local currency. So zloty for me, is it correct? Zloty? Okay, yeah. Was a new currency, so I actually need to understand how much is it in Swiss francs. And let's try to solve this problem with using futures, result, and chaining all the functions. I already prepared one nice function that displays the data. So what I just have to feed here inside, it's just the rate, the current conversion rate from zloty to Swiss francs. And the other one, it's just the one to display errors. There is, I hope there is nothing strange here. So I just display the error if something goes wrong. Okay, let's try to get the first one. If you're wondering, the server is running on my machine, so I don't rely on any problem with Wi-Fi eventually. And yeah, so the first important thing is getting the data. So let's create the NS URL, starting from this. Then we have the request. With our nice URL just created. And then we have a response that I'm gonna explain you later why I need it. No, that's wrong. And I need my nice error catching. And as NS error, and I'm gonna get this from here. And what I return is actually a result with my data retrieved. If I have an error, I return, of course, the error that my function created. Sure. Okay. Now we have, what's the other? Not initialize for sure. Okay. Sorry about that. Okay, we have the first function working, but does nothing at the moment. So our app, it's pretty much useless. I then have another function that takes data, and what I have to do here, it's just deserialize the data. If I have a huge quantity of information coming from a JSON, I want it to run on the background. But I can reuse this deserialized data anywhere. It's just a function that I write once, and then if I have a function that requires to handle my JSON for my currency exchange, or it requires another information, I'm gonna reuse it everywhere. So I just write it once, and then I'm gonna reuse it everywhere in my app. And this should be a little bit more again, we take the super nice do try catch error handling, and here what I have to create, it's a dictionary. And my JSON object from the data that comes from my function. I love fragments. And what I have to do is return a result of my dictionary. And of course, this is not an handle exception. Okay, so it should be casted as string any object. Okay, in this case, should be safer because I will have to check if it's an array or a dictionary for sure. But for this example, I'm gonna skip that and just assume that it's always a dictionary that it's coming from my JSON. And then what else I have to do? So I have this general, the serialized data, and then I have to process the data. I want to process my currency exchange data. So it's better if I call process rate. So I read the hub and I check how is my JSON, and this is actually the response that comes from my JSON file. So I just have the key rate and a float. So it should be pretty much easy, this method. And again, here instead I check if the dictionary has a float, and that it's a rate. And if not, what I have to return is an error, of course. So error, I have to create this one because the system is not going to pass it. So missing rate. Code -1. Absolutely nothing else. Unbalanced. And I return my rate. Casted as float. Okay. So now we have three functions, and we have to combine them in some way. The single thread way will include a Flatmap. So we basically chain one after the other all our functions, but it's not so much fun. It's a very bad practice because we have NS URL connections and synchronous requests here. So I'm not going to do that. It's very bad. What I'm going to do is actually using a future. For this example, I'm using bright futures. That is a very nice implementation of future and promises. So let's try. I create my future, and what I want to return is the retrieve data with the string URL that I have defined before. So this code is running in the background in the global queue. So it's concurrent. So every time I require to run this code, this nice retrieve data is performed in the background. But I have to chain it. So what I do here, it's create a Flatmap. I call Flatmap that it's just saying I chain the result, and what I get back, it's another result but I don't want to take care of the error. So with flat, I just get the value. If I write map, okay, let's see if you can read this. But and if I return my okay. Okay. So now the type of this feature, it's very small. It's a feature of string, any object, and a error. And this is exactly what I want to return. If I flatmap says that it takes the given function, process the function, and returns the value. If not, it goes through the error path. So I don't have to care about. Let's then combine again. I have my data, and then what it returns to the serialized data, it's my dictionary. So I write the processing rate from the dictionary, and of course thank you, good catch. Thank you very much. And so basically now we have processed all the 3 steps, and what we have back is our rate. So if I write my unsuccess in V and I check the type, it says that it's a float. And my unsuccess block, it's gonna take this float, and with this float I can call my display data that takes a value, and on error, that in case of some failure, I give the display error function. Okay. So if I run this, I can actually write the quantity of zloty that I just spend, and I get back and return the quantity of Swiss francs that are equal to the input quantity. So for example, yesterday I went with Maureen to a very nice place, had beer and hamburger, 70, and it's 80 francs on my side in Swiss francs. And yeah, this is actually how we can compose. It's one way to compose things and functions and blocks in Swift. But there is one thing that probably most people are going to complain. Here we have a warning, because then synchronous request is actually deprecated. Let's try to solve this. Let's use the new Supershine NS-URL session, share a session, and get data from that new object. So I rewrite the function that is actually the same, but on this time I use another version, and what I'm gonna do is I'm gonna use a promise. A promise is the evolution of the future. A future is a read-only placeholder. So when you declare a future you cannot write into the future. It just comes, and then you can actually read after it's completed. In promise, with a promise, you can inject the value. So you can basically perform a side effect inside. Let's create the promise, and in this case we're gonna use it because we need it. And here is NS data, NS error, what I have to return. In this case it's a future. I return promise and the future that I need. And in between, what I have to do is copy this, I think. Then I have my data task. Request with the block. And here we have data, response, and error that are actually all optionals. The promise can be completed successfully, of course, but can also be completed as an error. So what we're going to do here is check if we have an error. We have to complete the promise. With the error. Or if we have data, we pass the data to the promise. Try success with data. If we don't have any of them, because for example there is an empty data, we have to complete with the custom error. So in this case what we do is NS error, no data, new, should be okay, and okay, now should be fine. So what I change here is that I do this, and instead of calling Flatmap on the first future, I take this part and go here, and I have an error because I'm missing here. Here we go. So if I run this, it should work. I go here, I tap, I convert. No, doesn't work. Doesn't work. Unfortunately, I forgot one thing. I forgot to resum my data task session. And this is important, and it's very a tiny detail, but it's very important. Promise is used to move away from the imperative code. Every time you have a start or a resume, you are doing something imperative. And the promise is actually there for days. So you can create the promise, and then you declare your behavior inside the block, and then you resume or you start the operation, and then when it completes, you get all the result, the correct result. If you have an error, you have an error, of course, then it goes to the chain and display the error. If I have the correct value, then it displays the correct value. And it's pretty much here, so I have a very nice version, no more warnings. Let's try to see what happens if I don't have connection. So I kill the server, and it should not crash. Let's see. Could not connect to the server. And another example, what if I type random? Of course, there is no connection. So it doesn't make sense. So let's start again. Okay. So I try to get it, and the input is invalid. So you can basically change my example and make it better. Or you can check other nice example on the internet. And let's back to the slides to complete the talk. Yes, here we go. So to recap, a feature is a read-only placeholder for the value. It has a nice story. It was proposed a third valuation type alongside call by value and call by name. It was proposed as call by future, but yeah, it never had a lot of good supporters. And a promise is actually writable. Usually a promise is a subclass of future, but in other implementations it's just another class, and they wrap around a future, and it's actually good as well. And it's important to understand that in Swift, callbacks are imperative, and this comes actually from JavaScript. If you have a background in JavaScript, you hear it all the time. Callbacks are imperative. We don't have to nest them all the time. That's bad. So let's move to promises that actually are functional, because as you saw before, we can create small chunks, small blocks, combine them, and the world, it's a better place. And that blocks can be very well tested, because a unit test in a very small chunk of code, it's easier to write instead of a huge monolithic function. So some conclusions. Composition of data, it's actually a good way. I'm not going to say that it's the way, but it's a good way to control complexity and sometimes bring the side effects world under control. We have a lot of sources of side effects. If you take any fitness app, you have a lot of sources of side effects. You have the GPS information, you have the health monitor, you have the power if you're cycling, you have inputs of the user if the user has the phone in the hand. You have a lot of sources of side effects. And one of the way to avoid them is actually to compose these features in bricks, as bricks. And the code is actually more readable. I think it's way more readable, the example that I showed before, than the one, of course, that I presented on the first slide about ObjectiveC and nested callbacks. Where to go from here? Future and promises are a very good way to manage a very simple task, like as I shown before, if you write and press convert, you have a result. But if I want live result, what will happen with future and promises? I will have to create a concept that is called a cancellation, because if I type very fast, I will fire 3, 4, 5 futures, and in a concurrent queue, I don't know which one is going to complete before. So I can have a mess in terms of results. I can get the last one before the previous one. So order, when order is important, there is another way. And future and promise are single value. It means that you can have only single value, and when you start to create multiple promises, multiple futures, and you combine them together, sometimes it can be very tricky, and it's a non-trivial task. So this is actually a good opportunity to check, for example, reactive programming. Reactive programming is a natural evolution on data composition. Is the way that I actually use in my apps. For reference, I'm actually part of the project RX Swift. That is the implementation of reactive extensions for Swift. So if you have any question about reactive programming, please stop me around. And asynchronous programming is way more fun with reactive programming. A list of very good resources after this. Of course, checks RX Swift. If you have some time, check as well my blog. Yeah, XYZ is a domain if you don't know, because some people actually asked me if it was a domain. Brian Beckman, Don't Fear the Monad. It's a beautiful, nice talk about monads. I spoken about monad in all this talk, but I never mentioned them. What we saw today actually are monads. It's functional programming, but I usually prefer to avoid the word monad because it scares a lot of people. But whatever you saw today, the simplification of the code that I saw today is actually everything is functional. It's a monad. And Ashfaro functional reactive epsilon in Swift that has been recorded during the AltConf this year. Last slide is, this is actually a very nice text cloud that I created, mixing a lot of very beautiful articles about functional programming. And this is actually what is the result. I have a lot of maybe, nothing, monad, state, undefined, useful. They are scary words. I understand that. But don't be scared about the concept. Just check. Don't waste your time and say, I have to understand a monad to use a future. Don't do that. Just try to use the future, play with it, and then later maybe check what is a monad, and you're going to understand very quickly. Most of the time, people say that if you don't write one, you're not going to understand it. It could be true sometimes, but maybe it's better to play with it without knowing and then later discovering that, well, yeah, that's a monad. It's the best way. Last suggestion that I can give is if you are attracted from functional programming and you want to try the functional way, don't be mostly functional. Don't try to just remove side effects. For example, if you have to write very complex algorithm, sometimes it's very easier, like if you have to create the algorithm to check for the validation of a credit card. But if you have to write a bubble sort that has that doesn't exceed some certain memory in a functional programming, could be very difficult. So try to be pure functional when it's necessary and when you see a value, but also be imperative when you need, but be imperative. Don't just do imperative programming without side effects. That's not going to work. This is going to be a hell. So try to just select which paradigm fits better to which problem. Last slide. Thank you very much for your time. And for me, it's over.
Have you got any questions?
Thank you.